Okay, so any other questions? Yes.
I have a question about, like, I don't know if this relates to cookies so much, but, like, for the different frames in window. How does like content distribution work and all that? Do you have to just like trust them to deliver the correct content? Fine, it's good and not evil.
Got it. So a content distribution network is the idea that if you're shipping lots of bits over the network, you may not want to pay for it. Instead, you might want to find some other company that has a really good deal on bandwidth to deliver your data for you. And furthermore, that company can make it faster because they can put servers in every city in the country and put your content on those servers. And so when somebody goes to get it, instead of going across the country to your machines, they are just going to their local city server and downloading the content. So it gets much faster access to things. So it's great for distributing things you want to have places quickly. It's great for having things that are very big also. And so the way mostly that is used actually is that people use content distribution networks for static content, for images, for movies, for things like that, but not for code that is scripted. Because you're exactly right that the code downloaded from those places often has the wrong origin to access the other things that it wants to. So you embed, so you would have your web page distributed from one place, but then it would embed lots of objects from other places. So all the different graphical elements might be distributed via content distribution network. The content distribution networks are looking at how can they provide the ability to do a HTTPS secure connection to one of their servers and let you authenticate to the right website. So how can I go to Akamai, for example, go to Amazon.com, they give me the data even though they're not Amazon. So there's some tricks they're trying to play with the protocol behind the covers to like send information to Amazon behind the covers and get it back and kind of trick you. But it's still sort of an unsolved problem. Did that answer your question? Any other questions? Yes? There's a what? So the question was, if you put the IP address in the cookie, what happens if you have a private IP address? So one thing to think about is who creates the cookie? So the cookie is created on the web server, and so the IP address that goes in the cookie is the IP address the web server sees. So if you have a private IP address and you're talking, so one thing, if you're on a private network, you couldn't talk to the web server, so it's not such a problem. The bigger problem is when you're on a network and have like a network address translation box, so you have 10 machines that are all sharing the same IP address. And in that case, and you might have a different IP address on that network than on the internet. So for example, at home, my IP address is 192.168.2.10, but on the internet, I'm like 174.98.34.12. So all that matters is what address do you use on the internet itself, because that is what the server sees, and what the server cares is, are you coming from that same sort of public internet address? It can't see what address you use on your own network. But it does mean that potentially every machine on your home network could potentially use that cookie, which isn't great, but it's better than any machine on the entire internet being able to use that cookie. Yes?
Well, I think PowerPoint, when you try to set the password via HTTPS, you didn't encrypt. So now there's some website encrypted. Whether we should do that or not.
So in my example, the example didn't use HTTPS for the password. You basically, at this point, you should always use HTTPS for any sort of dynamic content. Anything that is HTML, for example, you want to use HTTPS for. You probably want to use it for pretty much everything. I mean, you'd like to use it for everything because you could potentially, embed a text through JPEG images or anything else.
Yeah, but my question is whether we should encrypt password again in my post request or not.
Got it. So here what you're saying is I'm just including your password string here. I'm not encrypting it in any way. So the challenge is if you're going to encrypt it some way, how do you encrypt it? So when you encrypt something, you need to use a key that the server knows. So when we get to network protocols, we'll see how HTTPS works. But HTTPS does indeed encrypt all of your traffic in a key the server knows. And so we're already doing that. And the problem is there's no other key that you have the server knows other than the one for HTTPS. So if you wanted to encrypt it again, you'd be encrypting it with the same key you're already encrypting your traffic with. So it doesn't really improve security. You could think about saying, just as we did in the password file, we're going to do some hash. Do some one-way function on the password before we send it instead. So that is something you might do. The problem is, remember, we're running in a browser. And so implementing a hash function in a browser might not be that convenient. And to some extent, putting the hash here doesn't really make it that much more secure. Because for one thing, if you use the password multiple places, it could be the same hash because we don't have a salt value to add a salt into the hash. And so it's more convenient to do things this way. And the security is good enough. Okay, so we're going to get started on SQL injection attacks, and then we'll probably talk about cross-site scripting attacks and cross-site request forgery next week. So these are sort of the top vulnerabilities that websites and web browsers have at this point. SQL injection is a way that you can basically cause a web server to run SQL commands that you provide. So you can do things like manipulate the data in the database. You can cause it to log you in without validating your password. You could potentially dump out the contents of the database. You could actually delete the entire database and prevent anybody else from logging in. Cross-site request forgery is when I can make you go to a website and do the things that I want to do, but do it as you. Or I can make you go to a website and do things on my behalf that you didn't want to do. And then cross-site scripting is when I can put a script on some other web page that you trust, and you run that script in the context of a website you trust, which gives it extra privileges. And so we'll go into a lot more detail on each of these. So we'll start out by looking at vulnerabilities in PHP. PHP is a common programming language. It's most famous, I think, at Facebook, where much of Facebook was written in PHP initially. And PHP is very convenient. It has very powerful commands in it. So there is a eval command that more or less says, run this command in the bash shell or something like that and print out the result. So here's an example where if we have, we are going to take this input that comes from a GET request. So this is sort of the parameters in the URL after the path name. And we're going to evaluate this in this ANS equals place. And ANS basically, think about it, eval basically will evaluate this as code. So what could you do if there was code like this in a website somewhere? So what this means is you have potentially the ability to inject code in here. Yes?
I was just going to say, add in your input, you do a period, single quote, semicolon, quote.
Right. So the idea is you can basically, instead of just providing a simple answer or something, you can provide some script code that the PHP will evaluate as code. Right? PHP is really just expecting a normal string here, where it's just going to print something out. But because it's going to embed the whole string in there, that string can have extra commands. So here, for example, suppose I pass in, 11 semicolon system rm star. What PHP will do is it will, say answer equals 11. It will then execute system equal, this running a bash script to execute rm star. And so the key problem here is that we are evaluating some input provided by the user, and if that input has any script code in it, we will run that script code. So the problem here is, the programmer didn't really think about what kind of input a user could provide, and they didn't think about what PHP will do with that input. So this isn't the only vulnerability. So here's another thing you might do. You might provide an email address and a subject, and then you might call the system to email something, to email it some standard message that you want to send to new users. What can go wrong here? So the way to think about this is say, well, what do we as the attacker control, right? We control that $ email variable. We provided this to the web server. So if we replace that $ email in the string that is passed to the system, what can we have it do? So this gives us the ability to sort of insert anything we want into that command line that it gets passed to the bash shell to execute. So we can provide our own information. If we pass in our email name where we want things to happen, but we can also pass in a command that says, dump out the contents of the password file and run ls. Run the password program and ls, so we can sort of cause arbitrary commands to execute in the context of the web server. This is more damaging because for a long time people would run web servers with root access because they needed to have access to open port numbers and do other things. So here you can sort of execute shell commands to do anything on the server you want as the root user or whoever's running your PHP code here. So there's some other common problems. So another problem is that it's common where you might provide some input. Suppose you go to a website and you provide a file name, and then the web server is supposed to find that file and return it to you by echoing out the content of what you provide. Here you could potentially change the file there to include extra commands that will cause it to print out more information than it wants to, because again, you're controlling what the input does. If you can provide like a report name and it will then include a file from the file system, you could potentially change the name of the file by providing, etsy password as the report name instead of the actual report name. So again, the problem here is that you're taking some input from the user that hasn't been sanitized, isn't trusted, and you are using it directly to access system state or to return information to the user. So the general solution in this case is that you really need to be better with inputs. You need to realize that any input from the user can be arbitrary. If you expect a particular format, like the name of your report has no slashes in it and no dots in it, then you should enforce that. If you expect that when somebody provides an email name, that email name doesn't have a semicolon in it, doesn't call system, then you should enforce the format on these things. So validate all your inputs. Strip path names on file names because you don't want path names, don't allow them. And then, in general, you want to think about how do you rigorously sanitize all inputs. So much as we talk about a reference monitor, similarly, you would like to structure your code so that all user inputs sort of go through one sanitation stage where they're cleaned up and checked for correctness, instead of having to remember every place you use user input in all of your code and check the validity of something every single time. So consolidating your sort of security functions in one place. So hopefully this gives you a sense of sort of how code running in your web server can be vulnerable because user input can be unexpected. I think we'll actually stop right here because it's 10:41 and talking about SQL injection attacks will take a little bit longer than 4 minutes, and I don't really think it makes sense to do it twice. So we will pick up with SQL injection attacks on Tuesday then.